Picture this, 1 million servers, 2 gigawatts of electrical power. That's the output of 2 nuclear reactors. And here's the kicker, not a single NVIDIA GPU in sight. Welcome to the future of artificial intelligence infrastructure, and it's happening right now in Indiana. I'm Will, and this is Mindcast, where we explore the ideas reshaping our world. Today, we're diving into what I call the Silicon Divergence, the biggest infrastructure transformation since the Industrial Revolution. And by the end of this episode, you'll understand why we're witnessing the end of the GPU era and the birth of AI superfactories that will literally reshape global power. Let's start with that mind-blowing facility in Indiana. Amazon is building something unprecedented, a data center that will house 1 million servers and consume 2 gigawatts of power. To put that in perspective, that's enough electricity to power 1.5 million homes. But here's what makes this truly revolutionary. The specification explicitly states no GPUs. Think about that for a moment. In an era where NVIDIA GPUs have become synonymous with AI power, Amazon is betting billions on a completely different approach. Why? The answer reveals the first crack in what seemed like an unshakable empire. For the past few years, we've been living in what I call the NVIDIA tax era. General-purpose GPUs like the H100 carry margins exceeding 1,000%. But here's the thing, and this connects directly to what we discussed in our previous episode about the scaling wall. These chips are incredibly inefficient for the specific task of AI computation. They're like using a Swiss Army knife when you need a scalpel. GPUs were originally designed for rendering graphics, for parallel processing of pixels and polygons. But AI workloads? They're fundamentally about matrix multiplication. That's it. Matrices multiplying matrices, billions of times per second. This is where the Silicon Divergence begins. Companies like Amazon with their Trainium chips, Google with their TPUs, and even Apple with their neural engine are asking a fundamental question. What if we stripped away everything except what AI actually needs? What if we designed silicon specifically for the mathematical operations that power artificial intelligence? The result is specialized processors that can be 10 to 100 times more efficient than general-purpose GPUs. But efficiency isn't the only driver here. There's something even more critical happening, a thermodynamics crisis that's forcing this entire transformation. But let me give you some numbers that will really drive this point home. NVIDIA's H100 GPU, their flagship AI chip, costs around $40,000 per unit and consumes about 700 watts of power. Now compare that to Google's TPU V4, which delivers similar performance for AI workloads while consuming just 200 watts and costing a fraction of the price to manufacture. Amazon's Trainium 2 chips are even more impressive. They can handle the same matrix multiplication tasks as an H100, but use 50% less energy. When you're running millions of these chips, that efficiency difference doesn't just save money, it makes certain types of AI development physically possible that would otherwise be impossible due to power constraints. And this isn't just theoretical. We're seeing the Silicon Divergence happening in real time across the industry. Tesla's Dojo supercomputer is built entirely on custom silicon designed specifically for training their autonomous driving neural networks. Meta has developed their own AI chips called MTIA, Meta Training and Inference Accelerator, which they're using to power everything from Instagram's recommendation engine to WhatsApp's spam detection. Even smaller companies are getting into the game. Cerebras built a chip the size of an entire silicon wafer. Normally, you'd get hundreds of chips from one wafer, but they made the entire thing into a single, massive processor specifically for AI workloads. The pattern is clear. every major tech company is betting their future on custom silicon optimized for artificial intelligence. Let me paint you a picture of the physical reality we're dealing with. Modern AI accelerators generate heat flux that exceeds nuclear reactor cores. We're talking about thousands of watts per square inch. Traditional air cooling simply cannot handle this. Even the most advanced server farms are hitting fundamental limits. You literally cannot pack these chips close enough together to achieve the computing densities that next-generation AI models require. This isn't just an engineering challenge, it's a physics problem. Let me give you a sense of just how extreme this cooling challenge has become. NVIDIA's latest H200 GPUs generate so much heat that they require direct liquid cooling. We're talking about pumping coolant directly onto the chip itself, like the cooling system in a race car engine. But even that's not enough for the densities we need. Microsoft is experimenting with immersion cooling, literally dunking entire server racks into baths of specialized cooling fluid. Facebook has built data centers in the Arctic to take advantage of naturally cold air. Google has developed AI-powered cooling systems that learn and optimize the temperature management in real time. And here's the really wild part. Some researchers are exploring cryogenic cooling for AI chips, using liquid nitrogen to achieve the temperatures necessary for quantum-scale processors. We're entering an era where advanced AI computation might require infrastructure that looks more like a physics laboratory than a traditional data center. Enter liquid cooling and a complete reimagining of data center design. But here's where it gets really interesting. This thermodynamics crisis is causing a geographic disruption. Traditional data centers were built near population centers, near fiber optic cables, near the coasts where internet traffic flows. But these new AI superfactories have different needs. They need massive, reliable power sources, and they need space for completely different cooling infrastructure. This is why that Indiana facility makes perfect sense. Indiana has what experts call stranded power, electrical infrastructure originally built for heavy manufacturing, steel production, automotive plants. That infrastructure is still there, but the industries that needed it have largely moved overseas. So we're witnessing a fascinating geographic shift. AI computation is moving from coastal connectivity hubs to interior energy hubs, from places like Silicon Valley and Northern Virginia to Indiana, Ohio, and Texas. These facilities are becoming the new industrial centers of the 21st century, but instead of manufacturing cars or steel, they're manufacturing intelligence. And this brings us to perhaps the most profound implication of the silicon divergence, the emergence of what researchers call the AI oracle. Now let's talk about what this means for different economic actors, because the implications are staggering. For investors, we're seeing the emergence of entirely new asset classes. Infrastructure funds are now raising billions specifically to build AI-optimized power and cooling systems. Real estate in these interior energy hubs is experiencing unprecedented demand. Industrial land prices in parts of Indiana, Ohio, and Texas have tripled in the past 2 years. For workers, this represents both massive opportunity and displacement. Traditional data center jobs, server maintenance, network administration, are being automated away by AI systems that can monitor and manage their own hardware. But new roles are emerging: thermal engineering specialists, power grid optimization experts, AI infrastructure architects. For regional economies, the transformation is even more dramatic. Small towns that have struggled since manufacturing left are suddenly finding themselves at the center of the global economy. But this comes with challenges. The power demands of these facilities constrain local electrical grids, and the specialized workforce requirements mean that many local residents may not benefit directly from the economic boom happening in their backyards. Here's a question that should keep us all awake at night. What happens when the ability to generate knowledge itself becomes centralized in the hands of a few hyperscale companies? The AI oracle isn't just about computational power, it's about epistemic power, the power to shape what we know, how we know it, and what questions we're even allowed to ask. When Amazon builds that million-server facility in Indiana, when Google expands their TPU infrastructure, when Microsoft partners with OpenAI, they're not just building faster computers, they're building the cognitive infrastructure of the future.
And this is where geopolitics enters the picture in a big way. The United States government has recognized that control over AI infrastructure is becoming as strategically important as control over oil was in the 20th century. This is why TSMC's Arizona expansion isn't just about economics, it's about what officials call AI sovereignty, the ability to produce the most advanced chips domestically without depending on supply chains that cross geopolitical boundaries. The trillion-dollar barrier to entry for building these facilities means that only nation-states and the largest corporations can participate. We're creating a new form of global inequality, not just between rich and poor countries, but between AI-enabled societies and those locked out of the cognitive revolution entirely.
The U.S. China chip war that we've been following in the headlines, it's not really about chips. It's about controlling the future of human knowledge production. When the U.S. restricts China's access to advanced semiconductor manufacturing equipment, it's not just limiting their ability to build better phones or computers. It's limiting their ability to build the infrastructure that will determine which language models get trained, which scientific questions get explored, which social and political ideas get amplified or suppressed. Now, let me bring all of this together and give you 3 actionable insights that will help you navigate this transformation. We are witnessing the industrialization of cognition. Just as the Industrial Revolution moved production from cottage industries to massive factories, the Silicon Divergence is moving intelligence from individual human brains to gigawatt-scale artificial minds. The scale is almost incomprehensible. We're moving from megawatt to gigawatt infrastructure. That Indiana facility alone will consume more power than entire small countries. Second, the Silicon Divergence is creating incompatible islands of computation. Amazon's Trainium chips can't run Google software. Google's TPUs can't execute Amazon's algorithms. Apple's neural engine works only within Apple's ecosystem. This isn't accidental, it's strategic. These companies are building computational moats that lock users into specific platforms. The open, interoperable internet that we've grown used to, that might be ending. We could be entering an era of computational feudalism, where your choice of AI provider determines not just what services you can access, but what thoughts you're able to think. You might be wondering, what does all this infrastructure transformation mean for you as a consumer, as someone who just wants to use AI tools to get things done? Well, here's the thing. You're already experiencing the effects, even if you don't realize it. When you use ChatGPT, Midjourney, or Claude, the quality and speed of your responses depends entirely on this specialized infrastructure. The difference between a query that takes 2 seconds versus 30 seconds often comes down to whether you're hitting servers running custom AI chips versus legacy GPU infrastructure. But there's a darker side to this. As these companies build their computational moats, you're becoming more locked into their ecosystems. Your ChatGPT conversation history won't easily transfer to Google's Bard. Your Midjourney art prompts won't work with DALL-E. The AI tools you rely on are becoming as incompatible as different smartphone operating systems, and switching between them is getting harder, not easier. This is the computational feudalism I mentioned, and it's happening right now with every query you run, with every AI tool you choose to adopt.
Third, geographic power is shifting in ways we haven't seen since the rise of oil. Coastal cities built their dominance on being connection points, ports for ships, hubs for fiber optic cables, centers of finance and information flow. But AI superfactories need something different: raw electrical power, and lots of it. This means places like Indiana, with their legacy industrial infrastructure, are becoming the new centers of economic and political influence. The Rust Belt might be about to become the AI Belt. Cities and regions that position themselves as energy hubs for AI infrastructure could see economic renaissance, while traditional tech centers might find themselves increasingly marginalized. Let me give you a timeline for how I expect this transformation to unfold, because understanding the pace is crucial for making good decisions. 2024 to 2026, this is the great build-out phase. We'll see dozens of these gigawatt-scale facilities breaking ground, primarily in the American Midwest and Southeast. Expect massive infrastructure investments, supply chain disruptions, and the emergence of new industry leaders you've never heard of. 2026 to 2028, this is when the performance advantages become undeniable. Custom AI chips will be delivering 10 times better performance per watt than general-purpose GPUs, making certain types of AI applications economically viable for the first time. 2028 to 2030, this is the consolidation phase. Smaller companies that bet on the wrong chip architectures will be acquired or shut down. The computational feudalism will crystallize into maybe 5 or 6 dominant platforms worldwide. By 2030, I predict that over 80% of global AI computation will be running on custom silicon in these specialized facilities, and the geographic center of the global economy will have permanently shifted toward these interior energy hubs. So where does this leave us? The Silicon Divergence isn't just a technology story. It's a story about power, about knowledge, about who gets to shape the future of human consciousness itself. That million-server facility in Indiana represents more than just computing infrastructure. It represents a new form of industrial power that will define the next century. The companies and countries that control the silicon fabric, the specialized chips, the cooling systems, the massive power infrastructure, will control the cognitive resources that everything else depends on. And this brings up some critical policy questions that we as a society need to start grappling with right now. Should there be limits on how much power a single AI facility can consume? When one data center uses as much electricity as a major city, who gets priority during power shortages? How do we ensure that the benefits of this AI infrastructure serve broad social needs rather than just corporate profits? The European Union is already working on AI infrastructure regulations that would require certain transparency and interoperability standards. China is treating AI chip manufacturing as a national security priority, with state-directed investment that dwarfs private sector spending. But in the United States, we're largely letting market forces determine how this critical infrastructure gets built, where it gets built, and who controls it. I would argue that AI infrastructure is becoming as strategically important as the interstate highway system or the electrical grid. It's foundational infrastructure that the entire economy depends on. But unlike those previous infrastructure investments, this one is being built almost entirely by private companies, with little public oversight or input into how these systems should be designed to serve democratic values and broad social prosperity. This transformation is happening faster than most people realize, and with implications that reach far beyond technology. As individuals, as communities, as democratic societies, we need to start asking hard questions about how this infrastructure gets built, who controls it, and what safeguards we put in place to ensure that the industrialization of cognition serves human flourishing rather than just corporate profits. That's a wrap on today's episode of Mindcast. If this deep dive into the silicon divergence got you thinking, please subscribe and share this episode with someone who needs to understand what's really happening in AI infrastructure. Next week, we're going to explore how this infrastructure transformation is reshaping scientific research itself, from drug discovery to climate modeling. You won't want to miss it. Until then, keep questioning, keep exploring, and remember, the future is being built right now, one server at a time.